In the 1980s, it was popular for state legislatures to take a look at seatbelt laws, in particular as they were considering various both human and societal impacts of serious or fatal injuries. In one particular southeastern state, which shall remain nameless, turned out to have about a 4.7% rate associated with severe injuries or fatalities before the law was enacted, and after the law was enacted there was about a 3.8% rate. And so one of the questions that's of course natural to ask here is the decrease a part of natural variability, or was it the case that the law was effective? How significant is this decrease of 0.9%? And of course we know politicians would always like to feel good about the idea that a law that they've enacted has had a positive effect. Of course, wouldn't we all? And part of the answer that came back was that a statistical analysis showed that there was less than a 3% chance to see that decrease due to chance alone, meaning due to natural variability. And in this segment we're going to get into how would you determine something like this? How do we know whether or not this is significant? How do you quantify significance to begin with? And so from a big picture standpoint here, you're going to learn that about some widespread tools, and by widespread I mean almost a vast majority of the statistical analyses that are done in conjunction with some sort of experiment are going to be using these tools that you're going to be learning about. And part of those tools you'll be hearing about p-value. And one of the questions we're going to be asking is, well, how strong is the evidence that this decrease is significant, for instance? And where does this 3% figure into all that? And this notion of what statistical or statistically significant means and what it doesn't mean. Right now, we just came out of a module where we talked about confidence intervals and how we use those to estimate population parameters, all from a sample, and that gave us a systematic way to communicate how we came up with that interval. And we talked about a percent confidence that was ultimately all about how we communicate the process that was used to come up with an interval. So that, for instance, we could say the true mean is in this particular interval, and I can state that with this percent confidence, which was not the same thing as saying that, well, the mean is in this interval with certain percent chance. That was what we were suggesting was not a particularly appropriate kind of statement. We're going to get to that, more of that kind of a statement here with significance tests that are broader than just hypothesis tests, but are, for us right now, going to be aimed primarily at hypothesis tests, where this ultimately is the other major class of inference, right? That key word there, inference, being that with confidence intervals we inferred something about the population from the sample. And this other major class here are these significance tests or hypothesis tests, where we're aimed at a different goal. Whereas before it was about point estimates of parameters and then getting this interval estimate of a parameter. Here this is going to be all about, is a result likely due to chance or to some other factor at work. If we're involved in the production of a part or an item and we see a variation happening, is that just due to chance, or is there another factor such as the machine going off, or maybe one of the ingredients that we're including has somehow gone off? These are the things that we're going to get into in a very direct quantitative kind of way. There is a very distinct relationship between the significant tests and the confidence intervals, and pull the two together we get interesting information, but they are distinctly different.